Eh, Vamos a darle la bienvenida al señor Richard Boyle. Un aplauso grande, por favor.
Gracias. Gracias. Juan the Magic Man, the David Blaine of South America. Let's give him a round of applause. Right. Well, gracias, Globant, for inviting me again. Gracias, Medellín, for inviting me to your beautiful city. ¿Puedo hablar en inglés? It's okay? It's mejor? Yeah, sí. So when I first was invited to come and speak with you, I thought, like most Yankees do, I know Medellín, right? I've heard of this place. I thought about conflict and some of the troubles and things that you had. What I didn't know when I came here, and what I think most people in the world don't know, is it looks like you've solved all your problems. You've got a beautiful city here. It's one of the cleanest cities I've ever seen. You've got an innovation center where you're working on new ideas for urban planning and building community and technology. I understand now why Globant is putting another big office here. So congratulations on all the work that you've done here. And I just want to say, I'm not going to dwell on this too much, but I came here a tourist. I'm going away an ambassador for you. If you don't believe me, go look at my Twitter handle and my LinkedIn page. You'll see I've already started telling people that they need to come and spend some time here and understand what's happening. So congratulations on everything you're doing. And yesterday I did have, after a couple of glasses of something, I did have one big idea that I'm going to share with you at the end of this talk. So don't leave before I finish talking, all right? And I'll try to be quick because I'm going to need your help. I have a big idea for your innovation center. So again, Globant asked me to come here and talk to you about something a little bit different. You've heard a lot today about using machine learning to become more efficient, to do things faster, to save money. And I want to talk about the human side of it. Although my firm does a lot of that automation work as well, I've become a lot more interested in trying to create that human and machine balance. And I want to help. We're going to talk today about how to use machine learning to create a deeper understanding of your customers, of employees, your coworkers, employers, and how we can actually build community like what you're doing here in Medellín, okay? But first, a little bit of perspective. I think perspective is important. Like, why am I here? Why am I here talking to you today? What's brought me here? This is a little bit about, like Juan talked about, my background. And I hope this makes sense, but this is my 27 years. Everything I've done in the last 27 years, I got onto one slide. If any of you are gamers, I think he talked about the game companies. And I think that's important to mention because my group, we built game companies with Tom Clancy. You guys know him, right? Anybody played Ghost Recon, Rainbow Six? All right, here's my people. We did a game company with Michael Crichton, Jurassic Park, ER, you guys know him. Ozzy Osbourne, of course, he mentioned, and Douglas Adams, the science fiction writer, and yes, Ozzy's the only one who's still alive. Draw your own conclusions. But back then, we were using AI, and we considered ourselves masters of artificial intelligence. But it was the old AI. It's when we were trying, if you're building games and you want to make convincing characters, convincing environments, you must have a mastery of that basic capability. But it was very different. In fact, we only called things AI if we hadn't done them yet. The minute you do them, they're just called code, right? But machine learning is very different. So I want to share with you how I came to learn about machine learning, how it changed my entire career, my entire life, and led me to stand here in front of you today. So, and I wrote a couple of articles about this. The first one was in TechCrunch. Do you guys read TechCrunch down here? This was back in 2014. Where I talked about this blend of humans and machines to accomplish tasks. And I really do think the most important thing any organization can get right is to figure out, look at everything that you're doing, whether you're a university or you're a company or you're a country or a city, and figure out what should humans be doing with their attention and their effort, and what should machines be doing. Anybody who gets that right is going to succeed. And I'll tell you that I believe anyone who doesn't get that balance right not only won't be competitive, but very soon will seem to be handicapped, right? So very important what's happening right now. So this is how I first discovered machine learning. Lockheed Martin, you guys know Lockheed Martin, aerospace company, bought my last company because we were doing some game-based simulation work on submarines and aircraft and different things, also in education and in healthcare. And while I was there, I was running a group called Virtual World Labs. So we were playing with AR and VR and artificial intelligence. And even we did buy the first quantum computer from the Microsoft guy was talking about that. We bought the first one ever. And I got to stand in a room with it and play with it a little bit until they explained to me that quantum computers don't use algorithms. And I had to go sit down for a minute and think about that. And then I had to lie on the floor and think about it some more. And then I just got up and left because I don't understand how it works. But Microsoft Research Labs actually invited myself and my colleague David Smith to come to San Francisco. And at the time they were working on this. You guys recognize this product here? Microsoft Connect. Back then it was called Microsoft Natal. And we were there trying to see if we could help them with the sensors. But very quickly we found out that their sensors were good enough. And we got very interested in what they were doing with machine learning. And this is an important point. This is how I got religion on machine learning. They were just trying to teach the Xbox what a living room was. Now that sounds simple to us, right? I know what a living room is. I can tell the difference between a chair and a table and a plant and a cat and a dog. But this was a very difficult computational problem back then. And they solved it by taking a supercomputer and giving it, like everything you've heard today, just a massive set of examples from all over the world, from everything you might see in a living room. And by the way, they'd already shipped Xboxes all over the world. They only had about 100 megabytes of available space on them. So whatever they did, whatever that brain ended up being, it had to fit within 100 megabytes, not gigabytes, but megabytes. And they did that with machine learning. So I went back to Lockheed Martin with a deep interest in this because, again, the interesting thing here is that you don't program anymore. You just need large sets of examples, hopefully millions of examples. And with the right machine learning libraries, it can infer its own understanding, create its own judgment. And that's really powerful stuff. And that's what we've been talking about all day. The first project I worked on was for the Department of Education in the United States. They had all this amazing content that was in places like the Smithsonian and in museums and that sort of thing. And they were trying to have humans look at it, scan it, take a picture of it, and then tag it so that people could actually find it. Well, humans, we're just too slow, right? When was the last time we had an upgrade? Anybody know? Maybe the Pleistocene, something like that. Somebody check my math. It's been a long time. So we built a system, again, using the power of machine learning that could just go through scanned in documents or look at images and say, you know, I think that is a Roman drinking vessel, or I think it's a Greek drinking vessel. And if it has a certain confidence level, let's say above 60%, then it would go ahead and tag it. But it doesn't tag it with just 2 or 3 things. It might tag it with 100 things or 1,000 things. And that's really the power of machine learning. So we solved that problem. It's something called the learning registry. So for a long time now, we've been trying to make that big leap from big data to information. But I'll tell you, there's a big leap from big data to information and an even bigger leap from information to intelligence, which is information that's been computed. And that's what we're trying to do with machine learning, not just look at big data. All right? And I'm going to skip through some of this stuff because we've already talked about a lot of this today. You guys, I mean, that was me with Nolan Bushnell, the founder of Atari. I also founded a Chuck E. Cheese because he needed a place to put his Pac-Man games. I saw the Pac-Man shirt earlier, so I was thinking about him. We all learned about the machine learning system that beat the #1 Go player in the world. That actually took a lot of us by surprise because we all thought it was going to be another 10 years. But it happened very fast, and all of this seems to be speeding up. You know, the change is really picking up. One thing I don't think we talked about today was this generative adversarial networks. Anybody heard of that? Raise your hand if you've heard of GANs. All right, a few people have. That's great. I had a chart on that, and we don't really need to talk about it too much. Just know that the reason this is accelerating is because the machines are beginning to teach themselves. All right? And I don't want to go too deep on that right now, but that's getting very interesting, very exciting, and is causing this to rapidly advance. You may have heard about the Google systems that were creating their own language that they were talking to each other with. It's getting weird. That's all I have to say about that slide. But some of the things we're able to do with it, and we did at my company, is, for example, take every single legal opinion in United States history. have the system read all those opinions. And we're talking about since 1797, across 400 jurisdictions, millions of documents. All these documents are very big. And again, it's understanding, not just tagging it and saying that case was about this, someone stole a horse, whatever, but actually really deeply understanding all of the concepts in all those documents and eventually understanding the law just by dumping all the data in the top. And it took about a week for our machine learning brain to actually understand all that. Now, this is where I want to go next. Well, let me tell you one more quick thing first. This is another thing I don't think we talked about today, so I snuck this in here. How many of you are scientists? How many of you have an interest in science? So we know about the scientific method, right? What was the old scientific method? You come up with an hypothesis, you design an experiment, and you start testing your ideas, right? Well, machine learning lets us do something completely different. The cool thing about machine learning is it gives us the new scientific method, which is now I can just dump all that data in the top and say, okay, machine learning system, find every hypothesis that might be useful to me. That's a very different approach, and it's still, a lot of us have not come to terms with how this changes absolutely everything. So think about that for a second, and let me just give you this scaffolding. And again, this is just my personal view, that in 2009, my whole world changed because I encountered machine learning. Of course, it was around before that. But I think of the first phase of AI from 1958 to 2009 was when you wouldn't ask a computer to do anything until a human understood it completely. Then you could sit down and write the rigid logic into the computer to tell it what to do, right? The breakthrough for autonomous vehicles and for machine learning is we don't even have to understand the problem anymore. You know, the mistake we made with autonomous vehicles early at DARPA was sitting and saying, how do you drive a car? Well, let's see. Human, I've got the wheel here, I've got the gas pedal. How do I drive a car? It turns out we really don't understand how humans even drive cars. So we can't tell a machine how to do it. And by the way, it turns out machines don't drive cars the way humans do, right? Because they have GPS, they have LiDAR, they have sensors. They've got different input and output sorts of capabilities. So the way a machine learning system learns to drive is very different from how humans do it. And that's something we've got to get more comfortable with. As we heard a lot earlier today, there's a lot of things that belong in the human space, and some things we're better off just letting machines do. Today, you can just take 100 hours of video, let a machine learning system watch it, and it can get out and drive a car flawlessly. Everywhere except in Rome, I like to say, where I'm going next week. You can't, I don't think even machines can drive there. And then the last phase is this phase of human behavior and understanding humans. And I think that's the phase we're in now. Like the last phase, we really couldn't find enough data scientists. How many data scientists do we have? All right, we're going to need more than that. All right, but the next phase is behavior science. So if you're looking at psychiatry, cognitive science, psychology, that's going to be increasingly important. That's why I reached out when I understood this and I want to understand human behavior better. I reached out to the top minds I could find. I found Dr. Jordan Louvier down in Australia. He's the #1 cited academic in this field of what's called choice modeling. How do human beings make choices? Where do they go to school? Who do they end up dating and marrying? Which things might they buy when they go to a grocery store? Which cars do they buy? There's a science and there are algorithms around that. And the other is Dr. Richard Carson, who's the head of the economics department at UCal San Diego. And he's an amazing guy. So we took their algorithms, put them on top of our machine learning system, and we ended up with something pretty weird. Like I said, I promise you it's going to get weird, and it's going to. So we looked at what's happening in marketing. How many of you are in marketing or want to be in marketing? Right? So it's all about like getting inside the customer's head. How do you understand them? How do we do it today? Well, today it's focus groups and surveys, right? Either in person or by sending someone an electronic survey. And you end up with these things we now call personas, which is a model of like, you know, who buys my banking products? Who buys my Tesla vehicles? How many different kinds of meaningfully different ways are there to buy my product? There's a whole science. In the US, we spend $3 billion a year just trying to understand that, except it doesn't work. One of the problems is it's static. People do it like every 18 months. And again, people change their minds a lot. The conditions change. We're changed by events around us. Even if I answered a question about whether or not I was going to buy a Tesla 18 months ago, I did, and I put down my $1,000. But you know what? Today, I want my $1,000 back because I'm getting offers from IBM and from BMW and from other people who are making really good electric vehicles. And Elon Musk is starting to worry me a little bit, if you're paying attention. So, and this is the other problem. I think this overstates it to say everybody lies, but read this book because it says, we did exit polls, we did surveys to predict what's going to happen with Brexit in the UK. Got it wrong. All the polls got it wrong, right? We had a lot of exit polls and surveys around the election in the United States. None of them predicted Donald Trump. But you know what did? Google search. Google search data predicted Brexit and predicted Donald Trump because people lie. And sometimes we lie when we don't even know we're lying. Like, how many glasses of wine did you have? Do you drink a week, right? All of us, it depends on who's listening. I might say, well, no more than 6, It's like, well, I have your Nielsen purchase data right here, and it says you bought, 12 bottles this week, and you live alone with your cat. So I think that's not true. And that's what you'll see in this book. So one of the things we realized, I talked about how we read the law. My system can read a lot of information and then categorize it and map it. It turns out, we learned this early on, that our machine system does the same thing with people. Right? We almost made a dating product. I saw Tinder up there on one of the customer list things there because we got into OkCupid. Do you have OkCupid here? But we got in there with a big data set, and we were able to essentially build a personality model of all these people, a very deep one just from what they say and what they write, right? And then all you need is an algorithm for what kinds of people work well with what other kinds of people. But one of the first things I did about 17 months ago now is I had my system read everything Victor Hugo has ever written, right? Turns out he's more of a romantic poet than a novelist. Did you guys know that? You guys probably do. And then I had it read everything written about him. And it built this pretty detailed computer model of who Victor Hugo is. First day, I just started releasing him on the internet, and I let him read stuff and go around and read everything on the internet. And you can't probably see the detail there, but he's actually reading thousands of articles, and he's putting a score next to each one about what he's interested in. What's attracting his attention? What's he interested in? So we thought that was cool. So we started doing let's do George Washington. Let's do Martin Luther King. Let's do Leonardo da Vinci. I now have a long list of these entities that I've released on the net. I can go visit every day and see what they're interested in, see their viewpoint through about how they feel about current events. That's why we called it initially the empathy engine. This is kind of how we do it. If I start with just demographic information about people and where they live, household data. In the US, we have census data. If I then have information from Facebook and social media, things that people have written, like I had from Victor Hugo, especially personal letters, I can build a sentiment model of who that person is. So now I have a kind of a psychographic. I have demographic, psychographic. And then if I have that data from Nielsen, I know you guys have Nielsen down here as well, that gives me detailed information about everything someone buys and everything that they watch on television. I can build and I don't ask people who they are. I don't ask questions. I actually model them from that data. And Netflix learned this. We talked about Netflix earlier. You don't ask people what kinds of movies they're interested in. Tonight you can go home and watch Lawrence of Arabia or Hot Tub Time Machine. Everyone's like, oh, Lawrence of Arabia, of course, beautiful, beautiful cinematography, great acting. What do they do when they go home that night? Watch Hot Tub Time Machine, right? You could substitute something else. That's who people really are. So that's interesting. So the next thing I could do, you can see the animation here, is I found out I can actually write to them. Oh, that's interesting from a marketing perspective, right? If I can practice writing, I can create an advertisement and send it out to the people that I'm trying to attract to my brand, and then they'll tell me what they think before I even try to do it. And again, these are representations of data, not asking people, because people aren't, when you ask people questions, whether in the presence of other people or even online, you don't always get good results. Sometimes, especially if you say, hey, fill out this survey and you'll get $1 or you get a coupon. What does everybody do? A, B, B, C, C, C. You know, you're not really thinking about it. But these data models are really accurate. So now I can write to people, I can write them a practice email, and they'll score everything. And I can see a score from each type of person about what they think about what I'm writing to them. So I can think of a lot of examples of like the CEO of United Airlines who should have used something like this, right, before he started that publicity disaster that he had. So another thing, I mentioned Douglas Adams. About way back in 1997, a long time ago, we actually built a game where we did natural language processing, where you could actually talk to the characters and they'll talk back to you. So that's an obvious step, right? What if I could actually talk to these characters and actually have them speak back to me the way we talk to Siri and Alexa? That is happening really fast. That's going to get really interesting, right? And I just happened to notice that we did this game, Starship Titanic, and if you saw this movie, it looks like they copied our game character. And then this. About not quite a year ago, my father died. And I know, por supuesto, right? Of course, I let 2 days pass. I had to do it. I had to try to build a model of my father. And the trouble with my dad, he's 85 years old. He wasn't on Facebook. He wasn't on LinkedIn. There was no data exhaust, right? Like, I have lots of data exhaust on all of you. I can build detailed models on all of you. But I didn't have any information about him except his military records, personal letters. So I had to go back and do like what I did for the Learning Registry, which is scan in all of that personal information, have that converted. The hardest part is with PDFs. I don't know if you guys have played with PDFs, but a lot of PDFs don't have text in them. They're just images. So converting that into something that the machine can read and understand. And I was able right away to build a model of my dad. And I'm just going to tell you, it was strangely comforting to be able to go visit him those first couple of days, and still is. I can go visit him today and see, like, what's he finding interesting. And sometimes I'm almost arguing with him because we didn't always agree on everything. But when I see him react to something like gun control or something, then, you know, I'm almost arguing with him. So that's interesting. And now I am at the point where I can actually write to him. And pretty soon I'm going to be able to talk to him and he'll talk back to me. I told you it was going to get weird, right? But just think about this, and I'm almost done. And then I want to give you my big idea, bigger than this even. But imagine being able to say, I have a series of important life decisions ahead of me. What if I could say, I want Martin Luther King, Leonardo da Vinci, Victor Hugo, my dad, my grandmother, my great-uncle, who I admired, and I want to see what they think about my choices. And I want their opinion. And they could give me maybe these Likert scale-like responses. So I'm getting their perspective on these big life decisions that I have. And there's other things we're doing, like there's people now that are beginning to build curriculum for schools where you can get inside the mind of figures from history, great writers. Anybody who I have enough data on, I can build a model where you can, again, it's that empathy engine. I want to see the world through their eyes and understand how they think, right? It's really powerful stuff. So we can do more than just automate tasks, right? So let's see if my big idea is here. All right, here's the big idea. I call it cerebro. Cerebro, how do you pronounce it? What if we could build a brain for Medellín? And it is a representation of all of you and everybody who lives here, the values, right? The voice, la voz, and valores, how do you say population, población, of everybody here, right? And so government now, when they try to think about, should we have a new transportation policy? What if let's give free bicycles to everybody or free electric scooters like we're doing in some cities in the U.S. What is everybody going to think about that? There are people that are like it, some who won't. And let's understand, before we go out and start testing this, let's test it in a simulated world where we have a synthetic population of Medellín where we can test these ideas. Also, any of the innovative ideas any of you come up with can be stored and managed within this brain. There's all kinds of cool things we can do with it. I am out of time, though, so I do. If you're a data scientist and you're interested in this, let's talk, because I think it's a really interesting idea. I just had it last night, but let's talk about it. And there's some additional reading that you might want to look into, and I really appreciate the time. Thank you for everything, Medellín.
Muchas gracias.
Gracias.